Hi everyone, in this video we're going to be making our own Linux shell from scratch for Linux in Rust using a couple baseline libraries. So let's get set up here. I got all my new streaming set up and we're going to do cargo newbies. We're using Rust of course. Oh, we gotta think of a good name. Let's say some kind of, let's say T shell for now, that's probably fine. And we're going to want it to be a binary because we're going to be running that. Okay, go in here. Alright, and we can delete some of this basic stuff. And we're going to need a couple libraries for this. So we're making this for Linux, so we're going to need libc to do fork and run some of the other syscalls that we're going to need to actually run the process when the person wants to type in their thing. So we can just pop over here to crates.io. libc, I don't know what the version is, so we're just going to grab this. Let's stick that in our toml file. And then there's a terminal library that we're going to use, which may or may not be cheating, but it's going to make some things a little bit nicer as far as printing goes. So basically with this, oh, they don't have much here, but this one's pretty cool. It's cross-platform. Actually, this might not be the right one. Okay, yeah, no, this is just for Windows, so that's unfortunate. Term Painter? It should have a lot of downloads. Because there's one that's kind of a low-level library that's used by a higher-level terminal rendering library that I've been looking at. Is it this one? I don't know. The thing is, we might actually skip this for now because we're just going to be doing basic printing and running of the commands. So this is going to be for more advanced things if you want to do like tab completion or just kind of re-rendering stuff in a nice way to show the user. But we could totally do a bash style thing that's kind of basic with not much. So actually, yeah, let's do that. We're going to stick with this, just libc for now. And that'll make things a little bit simpler, and we can always add that back in later. So just to kind of figure out what we want to do here, if I pop into bash, so we're going to be making sort of a very cut down shell, like really just the bare bones. We're not going to be implementing all the features of bash. Mainly we're just going to be looking for doing path searching for running the commands. So like if I echo, I haven't used bash in years because I'm bitten on fish for a while, so this is a little interesting. Okay, so yeah, you can see I have this massive path here with all of the different things I have. So basically we're going to be making sure that we actually search through this so that if a user adds something to this environment variable, then we can actually go and find it so they can customize what binaries get run. We're also going to be doing file redirection. So if we do like test to test.txt, and if we print that out, can't type today. Okay, yeah, you can see we can actually get that file. Right, so it's 5 bytes long. That makes sense for the word, and basically we could run echo to redirect this output into here. We also want to be able to do input redirection, so we should be able to do something like this, right? So cat, I don't know if you guys know this, but if you run cat without just printing some file out, it'll actually mirror the input you type. So you can see there's a double for whatever I put in here. And so if we pass in the standard input of cat this text file that contains this, then it's actually just going to concatenate and kind of mirror that back out to us. You can see that's working here. So we're going to be needing also something like this. So those are going to be the first two things we do. And then we're also going to do piping if we have time tonight, which I only have just around 2 hours or so. So we're going to see about that. So we have our main. Okay, so kind of the basic thing we're going to want here is a big loop where we read in the user's input for whatever command they want to type, right? Because I've been in this bash shell for a little while here. And so if I do a command, it's going to do it and then bring me back out to this. So actually, what we're going to do is have this big loop here, and eventually we're going to want to handle things like, in Bash I can do Control D to exit out of it, or I can type a command like exit. We're hopefully going to implement all these things to get it working, but for now we're just going to have it where it's like a normal console process, so the user's going to have to Control C to get out of it, which that's going to be interesting to implement because we're going to, of course, need Control C within the shell to actually send interrupts to the running process so that the user can actually kill something if they have like an infinite process or something like that. But for now, we're just going to not worry about that. And so what we're going to do is read in the line that they type in. So we're going to use... we could use libc for this, but the higher level stuff from the standard library tends to be a little nicer. So std, I think it's IO is probably the best. And I'm going to grab stdin and read a line from it. And for now we're just going to unwrap everything, because if somehow this closes, we don't really need to worry about it for now. And just to test that works, we're just going to print that right back out. And I'm on the nice new version of Rust, so we can actually do this variable line printing here, which is kind of nice. Nice. So that's okay. So when we do this read line, it includes the new line. As you can see down here, we typed in this key mash and then a new line, right? And that brought it to the next line. But then we printed out that string, which included the string and the new line. So that did the first new line. And then because we did print ln, then it did another new line. So we're actually going to have to get rid of one of those new lines to clean up the text a little bit. And then for running the program, right? Because if we type in a command like ls, right? There's going to be a new line here, but then when we're searching through the binaries, of course, there's going to be no like ls/n binary that actually has a new line in the name. So that's going to be important to get rid of. Let's see. I guess, yeah. There's more detailed documentation here, but I remember offhand that this does include the new line. So we're just going to do line.trim. We don't need to print that out again. And so the first thing is going to be just running a process, like not worrying about redirection or anything. So, okay, we should probably do path searching first. So, let's see. What's the best way to do this? So the variables aren't going to change. So what's probably easiest, we might change this later, of course. Forgot the API for this. Is there a path? Can I do this? Get all the args. It's args. What are you? Okay, it's an iterator, so. I know there's a better way to query just a single argument. Oh, it's var. There we go. This might not work. It might be an OS string or something weird. Let's see. We're going to unwrap. And I wonder what this has if it's not set somehow. If this will actually panic. Oh yeah, okay, if it isn't set. Which, this will probably never happen with path, but maybe if this is some kind of, it's run on startup weirdly, or somehow path is clear, which wouldn't be a very fun time for the user, but that might happen, so eventually, okay, we probably want to do, what does this return? String, okay. So we're going to do or else and then give it a closure. And we're just going to give it an empty string if it doesn't exist already. Okay, that's a string. Okay, we don't care about whatever the error was. Somehow path isn't set. Okay, so we do this. There we go. So this is the path I already have in my shell that I showed you guys in Bash earlier. And you can see it's all the same exact stuff. So we're going to want to filter this down. These you're going to want probably export and some of those other commands too. And then doing, what's it called? Yeah, so like another thing is you can set environment variables before you run a command. Right, so we can do something like this to cat out the A file and pass out this variable too, which is more helpful if you have like some kind of advanced program that has configuration through this instead of arguments, and we're going to want to support that too, of course. Okay, so if this returns, it actually might be nice to work with. There might be a type we get back from the standard library here, this like args type, and internally it's probably a hash map depending on how they implement it. And if it is, then we might just want to steal that and kind of manage our own hash map of the different arguments, because then what we can do is just have that and then have all the APIs for, you know, adding a key or removing a key or whatever, so that when a user types in something like this, where like they have this this echo or this cat we were doing with an environment variable, then we can just easily put that in the map, run the command, and then kind of get back the state we had before from that, instead of having to use like a raw hash map with all that stuff. So there's this args function. Okay, probably not, because it looks like they tie this to this args.os, which is, yeah, system dependent. And I think the only useful thing you can do with this is looping over it to do something with each one, which we want something a little more flexible. So we're actually going to probably want to collect. We're probably going to want to collect all these arguments into a hash map and then have a custom thing for path. So let's see. And actually, that's something I don't know about Bash. So if we basically what I'm wondering about here is if you set path explicitly before running a command, how is that used when resolving the actual path to the binary, right? So if I'm out here, right, in this random directory, I can't do test.sh because it's not there, and I guess it's not executable. So we just make it executable. We can of course do tshell test, right, and that works. But if we do this, that doesn't work, right, because we're not in that directory. But if I do this, this might not work with relative paths. We'll see. Oh, interesting. It does work. Okay. So that's kind of helpful. So then all we have to do is have this list of environment variables that we get from here, or a different command, and then basically take that in, and then before we run a command, we process all the environment variables, and then only once that's done, we actually run the command, right? Because here, test isn't in this directory, but we were still able to run it because it's this entry's in path, and we need to add this entry and then search it to actually run this. So that's good to know. That kind of makes things a little simpler, where we just read in whatever variables, and then when it's actual time to go, then we just look through that, and there's no weird edge cases. Okay, so we're gonna want and what type is there? Some kind of, man, I love autocomplete. Oh, and I hate it when it does this. And this can be a little awkward if they want to use non-Unicode strings, but we'll probably just assume that they always do that for now. This might be just a vec. Because I was originally thinking we need hash map to have like the key and the value for something like this, or this is the key and this is the value. But I think the old school simplistic way is you just have this, because anytime you would need to add something to a key with a value, you would do like this and then actually use path before, which Fish doesn't like, or maybe that's the wrong syntax for Bash even, but still, basically, you're getting the old value and adding the new value. Like, there's no distinction between, okay, well, we want to reuse this key, but then just add the single value of whatever this value was before. There's just, this is a value, everything here. This is the old value of it, just stick it in here and then add that. So, that it's kind of annoying. And I'm not quite sure about these types yet, because we might want to return process exit code, or I don't even know. Or maybe the output, or maybe we want to print the output right away, who knows. We'll just have this be a stir for now. And in my path, I wonder if user bin is in here by default. Okay, it is. And it's one of the last ones. Interesting. So I think what we can do is just search through the working directory first. Actually, there should be a proper resource for this that says what order to do things in, but I don't really care about that right now. So we're just going to assume that we search the current directory first, and then we're going to search everything in here and then run it. And then if that's not compatible with what they do, or maybe they have more options for finding the process we run, then we can always add that later. But for now, we'll make it nice and simple and do current directory and then in here for searching. So what we're going to do is have a program that's going to find the specific binary we're going to run, which I don't know if this is correct, because you could still technically have a shell script, and that's not really a binary, but whatever. So this is going to take in... I don't like calling this command because it's the same name as what's up here, but this is going to include the redirection in, piping, whatever. There might be multiple commands there. They might have and or whatever, right? So, but here, this is like the first part of the command, like echo or cat, or, their specific command that's in their path. So it'd be nice to have a different name for this, but I can't think of anything at the moment, so we might change that later. Okay. We'll do a closure so we can capture command up here. And this will take in the current path. Sure, let's use a path. I wonder if there's a better API for this that searches for a specific thing instead of having us do this actual searching. But we won't worry a whole lot about efficiency for now. And we'll switch this up to be an IO error. So that way we can use question mark, because I don't think there's really many other errors we could get at this stage. And this will be a reference to a path. We'll just do this for now so it stops yelling. Reader. Okay, so yeah, we'll do this iterator entry thing. Okay, we probably have to get the metadata and do all that. That's annoying. Yeah, no, we are going to use an FN then. And if we find it, we're just not going to return anything because this path is going to be what we're already doing, and somewhere we have to allocate memory for this path buff in order to derive this path from it. So it makes more sense to actually have the caller do the returning of this own value because it's going to be allocated in the caller scope. So that way we don't have to worry about passing stuff around. We just take a reference and then this thing that's returned will begin here, up here, and be returned down here if we find it. So that way we don't have to pass ownership around. And already I don't really like these error types. I guess we could do not found, which is a little goofy. I think this exists maybe. Too many. Wow, I thought like there's a 20% chance this would work, so nice. Yeah, whatever. And we'll just unwrap this here. Because if we can't read it or whatever, we don't want to abort out of the whole function for this entire directory. There's our entry. Oh, sweet. This can probably fail too. Yes. Nice. So if it's a file, otherwise we're going to ignore it. And symlinks are going to be a little annoying for now, so we can just have a little bit of extra logic in here. So we're going to compare the name first. Can we do this? Looks like it. So if they match, the problem is if it's actually a symlink, then we need to resolve it at that point to get the real path of the thing to run. So we're just going to do, if it is a symlink, right? Because at this point we know it matches, so we would return this and it would be run anyway. Otherwise, we're going to do return, okay. Okay. Yeah, this is not great code, but whatever. Okay, so we got that done. And now we're just going to have to search through our different things. So the first thing is going to be our current directory. We're going to want this. I think this is an option. No, this is a result. And if we can't get the current or whatever, basically a lot of this code is like, if we can't do it, just don't worry about it. So like here, all of this, if any of this fails, we don't really worry about it because that just happens on the file system sometimes. So if this is, what's the best way? It'd be funny if there was like some kind of reverse question mark that would return the OK variant back, so we could actually return this or like map it or something. We're just going to do if OK equals search. Oh, I don't have a keybind for this yet. Just go to the next thing with my autocomplete, so that's a little annoying. So if it's OK, then it means we actually found it. Okay. Yeah, so we find it. But this is going to be... Yeah, so right, because this is the directory, so if we find it, then we're finding a binary, right? So we need to return a path to that binary. So if we find it, we're going to have to push. So that's kind of going to be the same thing here, where we search through path, because we're searching through a whole directory. That's what this does. So we're going to have a similar push thing for everything in path. Okay, and we're going to need path as well here. And so path, okay, well this is fish, so it's being weird. If we drop back to good old bash, right, the separator is this colon. And there's probably some weird backslash or thing if you want to escape it for a file name, but we're not going to worry about that for now. We're just going to assume that no one uses that, because really no one does. Path split. So we're going to split it by that separator, which is a colon. I think that should do it. And then this is basically going to be the same code here. Oh, and the problem is if there's some kind of relative path in here, then this search will go to the relative path, right? Because we're doing this read-dir here. So that might get funky. And then, of course, if we find it, then we actually have to allocate this buffer. So this is going to be entry. I should just not worry about efficiency. Right now I'm debating between creating the path buff out here to allocate it once and then copying the entries into it every time so it doesn't have to reallocate, and then returning it once. But that's an optimization we can always implement later. This is a stir, okay. And the nice thing is we just push to it and then return it. And if we get down here, then we know it's definitely not found because we searched through everything. Alrighty. Unused. Yeah, eventually it'd be good to write tests for this, but doing tests is kind of weird because it touches the file system. So we're just gonna do some kind of manual testing here, like just stick something stupid in main. Or actually, we have this line, right? So we can even run process. We can do maybe we can just find the binary with the command. For now, we'll just type in a single command, and path is gonna be vars. Is this Yeah. So when we get it from the system, it is a vector of strings for each argument. But the problem is, at runtime, it's a lot nicer for export and things to have this as a hash map, or maybe even a wrapper struct that contains a hash map, and then we can just do like add var, remove var, get var, whatever, right, on the struct. But here we can just do it's going to be a little complicated. We're going to need some space in here. So yeah, that's funny. We will end up needing this hash map. And what I'm thinking is, if we have a variable that's, or an environment variable that's set like flag, right? Oh, maybe you can't do that. Oh, you need equals, right? So we're setting this environment variable, but it doesn't have a value. So we'll just do an empty string if that's the case, which should be fine. So we just have to be careful with this split. Split it here. Alrighty, so if we're parsing this, I don't know actually. I think this can just exist on its own, right? Or I'll just assume that there can be only one part of this. So we're going to do the key equals parts dot next. Nope, not that. I don't know why it's defaulting to that now. That's really annoying. And string new is basically free, right? Because it just creates this empty vec. Ooh, what? What? Oh, they're on a map here. To owned. This should be string now. Yeah, this new should work, right? So if we go here and look at vec new, you can see that there's this raw vec thing, and it's all const, right? So it just sets the length to 0, and it uses this constant here, which is this global new in, yeah, which ends up creating this dangling pointer, which is basically for, yeah, it's well aligned for this type, but it's not null. So we're not going to access this because its capacity is 0, right? But this is a pointer that just kind of exists, and we can fill it in by default in the structure. So it basically means that new doesn't allocate anything, so we can actually just stick this string in here, and the compiler should make it really nice to actually initialize the string's struct data, instead of otherwise we'd want to do like where we do elsewhere, where we want to do or else and then have it execute the closure, because it only runs the closure when it needs the value, whereas here it's going to have to construct the string every time because it's passing an owned string, an owned t, into this unwrap or. But this creating this t is really cheap, so that's fine in our case. Okay. And here we're going to do key val. Maybe we need better naming, who knows. That's good. Okay, why are you crying? You're an str. That's the problem. Alright, so then this should be a proper thing. And for this, and we're going to want this to be mutable. Oh, actually not for now. And when we're running something, this takes Other vars. I'm gonna have to change this here. Just copy the type. And we're just gonna assume it's always there. Maybe it's not. We'll probably have to fill in some kind of default up here. Borrow, okay. This might not work because it's a path, we'll see. Okay, maybe we'll, who knows. Alright. Oh. Interesting. Looks like an L, but it's not an L. That's not an L. Shut up. Oh, I'm a dummy. Okay. Vars. Very nice. Why are you crying? Oh, this probably has its own looping thing. Yeah, so we're awkwardly collecting this and then just immediately looping. Here we can just switch out this closure to basically have this be here. And we'll just have this be a gross mutable map that we push to. We're not going to need the type hints anymore. Make it empty, and then down here at the bottom, instead of returning this, we're just going to do vars.push. And the types, we might have to say what type this is. Insert, okay. I guess it didn't take it too far. Okay, we don't need this collect anymore. These are just looping. And this is probably some kind of result. Oh, what? Oh, ha! Okay, this makes it easy. This makes it stupidly easy. No, we're gonna do this instead. We're gonna do our good old collect. Can I figure this out? No way. Oh, is HashMap the only implementation of Intuitor? Yes. Let's go. Okay. Sweet. So we can look up binaries. Let's see if there's something elaborate we can find. Alacrity. Yeah, that's in my cargo bin, which if I go pop into bash for a second and just temporarily screw up my path. Oh. Maybe it stops me from nuking my path. Oh, wait, okay, it is in there. That's kind of cheating. Okay, what's useful in here? Flutter. Flutter. Okay, so this is, you can see it's only in here. And if I run it inside bash, it's not found, right? So if I run it in our thing, Flutter, it finds it, right? So this is actually searching through my paths. That's good to know. That's all working. Okay, so now instead of panicking, we're going to actually want to do our fun fork stuff and do the argument stuff. And we're going to want to split this command also. And this is going to get interesting once we're actually parsing for the way we split, or sorry, the input and output file redirection. And with, like, if you want to have an argument that's a string, right? So you have to, like, escape it in bash, all right, and do your thing, and then do this. We only want to count this as one argument that we actually send to the command. But if we're just looking for spaces here, we don't, Rust split doesn't know about our escape, right? So it's going to try to split on all of these individual spaces, which isn't going to work. So we'll fix that later, but that's fine. Okay, that's nicer, yeah. We don't have to change around the stir. And here we're going to just search for the first thing. So if I do this and do like Flutter run, it still finds it because we're only looking for the Flutter part. Okay, let's see here. Okay, this is going to get into the fun libc stuff. So, actually, we're probably going to want to read the docs on this because I'm kind of unfamiliar with it. So this website's kind of garbage. We want the man pages because they're actually legit. And there's probably a more efficient way to do this because this clones everything. Like, I know there's a new thing called there's execve, but we don't want that because it'll replace our current process. There's some way to create a new process that's kind of like doing a fork and then an execve, except all in one syscall, and then the system doesn't have to go around cloning all your stuff and then switching it out for a different binary. But this is kind of the classical way to do it, and it's the simplest, so we're going to stick to it for now. And yeah, this is going to be important here for the file descriptors stuff. Oh. Is there a... Okay, let's see. Yeah, I think we will have to use libc. It'd be cool if there's something from Rust, because it looks like this is different from... Oh, this is libc versus calling the syscall. Okay, sweet. So that's, we don't have to worry about that. Probably need the docs for this. Oh, and it's unsafe, of course. Nice. Actually, how well is this documented? It might be all auto-generated. Ah, okay. Well, that's fine. We'll just read the Linux docs then. Return value. So 0, okay, the PID in the parent, 0 in the child, and -1 on error. and no child is created. Okay. So now we're going to fork. This is really a maybe PID. Actually, no, let's just match directly on this so we don't have to figure out how to name a weird variable. And so if it's 0, then if it's -1, and if it's anything else, I really can't type today. I'm going to stick this up here so we can do the error handling first. Okay. Yeah, for now we don't care about error handling, so that's fine. Alright, let's see here. Ooh. Okay, we don't worry about that. Okay, so we find it. Oh, that's interesting. Yeah, because the printing, we don't actually print this out until after, even though we're actually running echo. And that looks like I got a reboot. I've been alive forever. Ouch. Okay, so yeah, looks like fork works. That's all good. We don't worry about error handling in case the kernel's out of memory or whatever. We should probably check the error code so at least the user can get some idea. But that's fine for now. Like, when does this ever fail? It never fails. And then in the child, this is where we're going to have to do the redirection. Well, maybe or maybe not, depending on the rules for inheriting file descriptors. And we're going to do wonk docs for this as well. So what's going on here? This is going to be annoying to create all of this, these stupid C arrays. Ooh, okay. So yeah, I guess if there is a shebang, then we should still be able to run scripts with our shell, which is kind of nice. Yeah, so this is pretty straightforward. We're just basically passing this as like what kind of ends up getting passed to main. So we're going to have to create this from the arguments they pass in. This is going to be from all of the environment variables we've set up. And then this is just kind of random. Because yeah, I think you still have to pass the program you run as the first argument, because that's what C expects. Because at this point we already know, oh no, this is the path, okay. So yeah, so if they do something like echo, we still have to pass this as user bin echo, and then this would be like echo whatever, and then these would be all our variables. Okay, so let's set that up. And we're going to want to do some setup here. Let path name, and we'll call it the same as what they have, just for clarity. And this is going to be bin. We're going to want to do this here. What does this return? We'll just unwrap this, fine. Actually no, if it's not found, this is annoying. We'll do some error handling here, because that way if the user types in something wrong, then we don't just blow up the whole shell. Oh, what's that? Failed to find. I just want to check to see if this works. Don't cry, don't cry. Ah, that's funny. Okay, so yeah, that's where we're running it. Failed to find this, and entry not found. So we should make this a better error, saying that we can't find the, because this doesn't really help. Because really, it's looking in the directory entries, but that's not great for the user. But we'll fix that later. Actually, no, we'll fix that now. Okay, so we found it. The path name is going to be the full path. This is going to get weird. So we'll worry about that later. argv. This is a pointer to a char pointer. How are we going to do this? Okay, we're just going to use a cstr and then reference the data that we already have. I mean, arguably we could use a local array or something, because this is just going to be pointers and they're not going to have a million arguments. But we'll optimize that later, of course. We should maybe map this. Let's see. Yeah, so here we just look at the first thing for this, but now we actually need everything. This is okay. We don't want to do it. Oh. Yeah, so these the C string, it's null terminated. But this this split we're doing obviously isn't null terminated. We could do something goofy where we sub out the spaces for null terminations and then we don't have to copy all this. But again, that's going to be an optimization for later. New. Are you crying? No, you're going to be C string. Oh yeah, and I guess if there's internal null characters or something, then we can't do that. But we're just going to assume that they're not being weird. Okay, so we got that. This is a pointer to this. have to do some casting here for sure. Actually, how close are these? Yeah, because we don't want to just transmute here. But this has to be owned. This is going to return the pointer. This is sad we have to do all this stuff, but whatever. Alright, we're going to stick in a use because there's going to be a lot of this for the stuff we're doing. Okay. Well, I'm surprised that those types work, but I guess that makes sense. Okay. Okay, this is going to be literally the same thing for the environment variables. And I think this only returns if there's an error, because otherwise the whole process gets replaced. This is going to have to be null terminated. I think C-string or path buff actually has similar constraints where there can't be nulls inside of it, because you can't have that in a file name. So that would be nice if we could do that. What does this have? Into vec of U8. Let's. I feel like that would have that though. That's so weird. Let me look at the docs. Maybe this. Yeah, because we're gonna have to copy it anyway, because I'm pretty sure this isn't the stored with the null termination character, so we have to stick it in other memory as well. So, but that's fine. That looks like we can do to. Huh, now we gotta convert from that. Nice. There's definitely a nice way to do this. I don't know why this is so painful. what is OSSTR? Oh, this is weird because, yeah, on Windows with UTF-16, this isn't just a trivial copy. Ah. Yeah, you know what, screw it. We're just going to convert this to a string, hope there's nothing bad in it, and then create it. That's that's not great, but that's easier. And so this is this. We're gonna have to put them back together somehow. So when we're mapping, we're not going to map from command, we're going to map from bars. And this is a lot more complicated, so we're going to go here, and we work, okay. And we're going to have to do escaping here. And we're going to push this other one, and we're actually going to push also. And so this takes a char, right? I wonder if, because when we construct the char, we have to do all that Unicode stuff and then convert back to UTF-8 to actually push the string. So I wonder when we do the equals, if this is actually faster even though it's pushing a string. I don't know, something to benchmark one day. And this doesn't... this is more of a fix me. Actually, all these are fix me's. We can expect here. We'll be nice. Anything else we can make better? Actually, I don't know why I copied that. Yeah, I mean, it's going to be a different message every time. And this is probably fine as an unwrap, right? Because if the original data is this path buff, and that doesn't accept nulls in the middle, right? Then when we convert to a string, there's already going to be no nulls, so then there's nothing for this to fail on. So that's probably fine too. Okay, EMVP owned, we get this back, and we convert this with the pointers. Okay. Okay, so I run cat. I run just echo. Okay, looks like it just prints a new line, so that's good to know. Res is empty. What happens if this errors? Huh. Because it looks like this function doesn't return from what my thing says. Is this type? Ooh. Oh, that's very tricky. Okay, so if it's successful, it doesn't return. So it only returns if it's an error, and when it's an error, it only returns -1, right? So the cool thing is, and then the actual error is an error no, right? So if it does return, then we know it was an error. So actually, this is an error here. And I think we can do... There's like last or something here. Last OS error. Does that return this? Oh no, that works. Okay, let's see what that does. Bad address. Oh, that's a nice PID. Oh, okay. Yeah, if only we could rerun it and get all 2s, that'd be pretty sick. Okay, never mind though. Bad address. What is this? I've never seen this error before. So there's all this. This is the only thing with address. Okay. Oh. These have to be null terminated. So before we get this final pointer, yeah, these words, so down here, when we actually call execve, right, we're only passing a pointer to the first one, and the kernel doesn't know how many there are because we don't give it a length, right? So the way it knows is that we have these valid pointers to actual things in here from this array, but it doesn't know it's at the end until the last one. So probably what's happening is it's walking all the pointers, and then it gets to the last one, and then goes to the next one, and there's no null to tell it to stop, right? So it keeps going on, and then it eventually encounters a bad address, and then that's when it bails out. So we're going to have to make this mutable, actually both of these mutable, because it's the same problem. And let's put something down here. EAVP. Alright, let's see what this does. Okay, that fixed it. Sweet. Echo. Let's go. Okay. Well, we have a really garbage shell. What else can we do that's fun? Huh. Okay. That's probably because we don't set up the input-output, but we'll deal with that eventually. And so here we actually don't want to do this, and we're eventually going to want to wait for the child process and do the IPC, or not the IPC, but read the streams and all that. And we're going to probably want to ditch some of these things. Oops. We're going to have to return here now. Oh yeah, so we actually do want to wait PID or something down here, and then we're going to have to figure out how we read from the streams. We're going to get the result code too. I think it's just wait. Oh, and this is funny, because now, because here, right, in this match, we're in the parent, and so we only want to wait in the parent because the child, that's actually here. Yeah, so this isn't going to return if it works. Huh. Ooh. Yeah, because so now this is running in the child, right? But if this execve fails, it fails in the child. So this is kind of weird to print this here. But here we're in the child, and we don't want to return back. So here we actually do exit 0. And actually, I wonder what this does, because we're using libc so much, it would make sense to do libc exit, because this is probably doing the same thing eventually. Oh, okay. Well, this does rust cleanup, and then does the same thing. So, yeah, libc exit. Nice. Okay, so, yeah, we'll just stick with this, so then at least Rust can do stuff. Nice, okay. And then, so if we're in the parent, and we get the child successfully, then we do want to wait. And at that point, once we've waited, we know that it worked. Oh, whoops, and this is just wrong. Oh, getting tired, guys. Wait. Oh, wait status. We're probably going to want wait PID. Yeah, so now I'm looking at this. This is the one we're calling, which is probably not what we want. Oh, this might wait for the current process or something. Okay, that's interesting. Yeah, so it looks like we could just do this calling wait is the same as this. So, and -1 means any child, like we only have one child, right? So then this -1 is going to match the new one we just created, but it's a little nicer. We're just going to be explicit about it and call wait PID with the exact PID. And I think this was the last one's a timeout or options. Okay. Yeah, so we're going to use this one with the child specifically. Wait PID with child status, and let's say 0 for now. What's it called? Wait status. No idea what this is. I wonder where this struct is. Let me just search. W status. Interesting. It's probably gonna need null mute. Yeah. So what is this? That's terrible. I can see in the docs here, wait PID, and then we'll just look up this type. Oh, huh, I thought it was some kind of fancy struct. It's just an integer. Nice. So then I guess that means what status. This is probably just the return code. Ooh. Oh no. Are these macros? That's scary. I wonder if this will work. Oh, because yeah, this isn't the actual code because the syscall might fail. That makes sense. Oh, that's funny. Yeah, cat never exits because we wait for it, but the stream's input never closes, so cat just keeps running forever. But we just keep running cats. That's funny. Or do we? I don't know. Maybe this is just running in cat. Oh, this is, yeah. Huh. Yeah, we're gonna do interrupts as the last thing. Because killing the whole shell is very important right now, as you can see. And wait, PID, return code. Let's look this up. We're gonna do a match on this too. Okay, so. So the thing is, it only returns -1 on failure, right? And if it succeeds, we don't really care. And we're going to want to steal this thing again. Okay. Wow, that's slow. Exit with 0. Okay. Ooh. Ah. Okay, yeah, because the Control D program doesn't exist. Actually, does there exit program? Interesting. Okay, that's a shell built in. Yeah, we probably want to implement that first. Just in case something goes wrong, we can quit out of the shell. So, and before we do the binary, let's just do like shell run shell internals. So this will do things like cd or exit or whatever. And we're going to want a better way to deal with this. What should this be? That's annoying. It's going to be annoying for a lifetime. And this is really just a wrapper, so we don't need to name it. Why are you crying? Oh. Have to be tick C because this ends up being tick C. Split, okay. This is better as an assert. Alright, so this will clean up a lot of stuff, then we don't have to worry about okay. Please. Oh, is this back hitter? It's slice hitter, what? Rovec, that's interesting. Oh. Oh, that's convenient. Thought we were gonna have to do weird stuff. Okay, and so this is gonna be just the 0 thing, and we check before that's not empty, so this is fine. And we'll do the normal derives here. Oh, what? What? Oh. Is there a derive format? Because this is pretty simple. Oh, okay, no, whatever. Oh, come on. What? This is display. FMT display. Because I don't want to debug it. I want to get a nice... Okay, whatever. thought there was a nicer way to do this. There definitely is somehow. That doesn't work, whatever. Ah. Yeah, I typoed, and so I hit backspace, but that didn't do... Wait, what? That's weird. I mean, this is pretty clearly Flutter, but it got eFlutter. That's unfortunate. And exited, okay. Commands cannot... Oh, huh. So that's cool. So I guess when I do Control D, that's end of stream. So I should handle that better. So here we do up here Command New. It really should be like a shell exit. Like we could just do process exit, but there might be some other stuff we want to clean up. But we just want to exit for now if we get that. So now if it's empty and I do Control D, it should work. Or if in shell internals, bin path, so I do bash. Oh. Yeah, we should probably do error codes eventually. But I feel like with CD and some of the other internal commands and like export and stuff, we're going to want to have like a nice fake command framework, right? Where we can easily list out what arguments we take in, do the verification, and have all of that code all in one place. And I'm not going to bother with that now, so we'll just do a trivial thing where if they type in exit, they can do like... They can literally do this, right? And it would still exit the shell. So, but we're not worried about that. I don't know what else we need. Actually, does ls work in here? Oh. There's nothing, we don't care. That panics. Exit works. You panic. Okay, cool. Oh, and that's interesting. Color works. I guess means we get the default streams, and then ls handles the color for us because it just goes to our process, and then it just works. So that's kind of a neat quirk of Linux that we get. I'm going to take a quick break, get some water, and I'll be back in maybe 2 minutes or so. Oh, I got like 30 minutes left, and I'm going to head to bed. So we'll see what more we can get done. Hopefully we can do maybe some of the piping. But we'll definitely have like a solid, kind of really basic framework done for tonight. Alright, I'm back. Let's see what we can do here. So CD is pretty important. Let me think. How do we want to implement that? Probably the best way. I mean, we could have a variable, of course, and like kind of look up our current directory when we start. But it might be easier just to change the current directory of the process. So, oh, that's cool. So if I do enter, that kills it. So we might want to make that distinction between Control D. I guess that's standard input exiting, and the distinction between that, and then if you just press enter, right? Because in my normal shell here in Fish, or even Bash for that matter, right, I can press enter a million times and it's still a shell. So here we're gonna say and I mean, like, we should implement indexing here so we can just do this a little nicer. Forgot what the thing is. In path. It does support relative paths. Yeah, but can we give it a relative path? Well, I guess we gotta find out. Match and return value 0 on success. Fail. Ah, okay. That's going to be important. Yeah, because we're handling it here. We're actually exiting and then trying to run CD, which doesn't exist. So here, we're going to return OK, and then error. So OK is like, okay, we handle this, everything's fine. Error is like, we weren't able to handle this. And can we use never type in this version? I think we can. Sweet. Okay, so that makes it nicer. And up here, it's going to cry that it's unused. Ooh, and so our garbage coding style, where we have this result of two empty things, is funny that we can just question mark this, right? Because we return error. Actually, no, this should be the opposite. Okay, never mind then. Well, we will need to match here. So, okay. Then so this is going to be fail. That's a real directory. Okay. Oh. And I want to get rid of this garbage. /test. Okay, so we have to do relative handling before we send it. Because it could be hidden if it's local. So if it starts with a / it's definitely absolute. So if it's not, then it's probably relative. So it doesn't start with that. And if it does start with that, then we're good. So if it is... How do we do before? Okay, this was it. Where is our thingy? Shell internal? Okay. So if it is relative and we don't have a dir, we're just going to unwrap, because if this fails and we're trying to do /, I don't even know what that means, so. Path buff. That's going to be annoying again. Does this have a push or anything? No, okay. This is an str. I know these variable names are nasty, but whatever. And we'll only do the conversion at the end once we've pushed everything. And this has to be mutable. Path it, and then we make it. Okay. Oh. That's awkward. Yeah, okay. Whoops. This is... Huh. Okay. And we're also going to need I don't know if we always need this, but I'm just going to assume that we do. Nice. Is this a command? Nice, it is a command. I'm going to cut down on some of these prints because we have this thoroughly debugged for the most part. If you do CD, that fails. Okay, so we might want to resolve this path or normalize it or something. It's probably in path buff then. Ah, but then we're gonna have to go back to a string. That's annoying. There's definitely something for it. I know I've used it before. Yeah, I don't want to use another crate. I wonder what I've done before in here. Yeah, I've done it. Okay, it's in util. Oh, here's it. Yeah, I knew we had it. Yeah, this is a file server thing I'm working on, like a web interface where you can, kind of like Google Drive, so just so I can self-host something, but I haven't worked on it in a while. We'll just take path. Yeah, eventually. Okay, sweet. And real quick, I'm just gonna fix the / thing. Yeah, so that's cool. The Canicalize takes this and turns into this because then we end up going here. And so, oh, that just works. Okay, nice. We don't have to do anything else. That's fantastic. And so if this fails, we do want to print out this, because that'll be very annoying if we actually run into an error like that in the wild. And I have to fix, so I've disabled my HJKL or IJKL keys. So if I have to move a single character, like I only use like W and E, or I go into visual mode and then I can use it because that's normal. So if you ever see me doing this to do one character stuff, it's because it's sort of like a bad habit of muscle memory that I developed when I was trying to break the habit of using HJKL to move around. So it's yeah, something I'm working on. I got a bit more time. Let's see what we can do here. And this exited with 0 business. There's definitely not going to be a project here. Yeah, so it exits with this code. The problem is having this being printed is a little annoying. Yeah, every time especially. So I'm going to actually get rid of that. So if we're only going to do that, right? So if we do tree, that works. But flutter run, then it will give us the exit code. Because sometimes this is important. But at least we have this. And what I should do is in the top of this loop, before we read, we're just going to print this can be our little shell character. Is it print? Oh, duh. Oh, huh. I guess that works. Wow. Can we do this? Holy cow, that works. We can exit here. Oh. Now we're in this shell. Wow. That's crazy, guys. Just look at that. Linux is awesome. Like with this code and not even any special handling, htop works. BPY top. That's the cool Python one, I think. Oh no. Oh, BPY top. That's not what I typed. It's kind of slow because it's written in Python, but it looks really sexy. This works without anything else, just with us inheriting the output streams. This works. We can run a shell inside a cell. Like here, I'm 3 deep. We can go to 1 deep, which is funny because now the shell cargo run command exited and it prints this because it's waiting for another command. Alright, I can exit again and get this, and then exit again finally for the last one. So all with that and the power of Linux, we can have shells inside shells and htop and stuff just from how wonderfully everything's set out. So with that, I'm going to call it for a night. I think we made some good progress here, and I hope to have some more videos coming out in the future. We're going to finish this up, and I got plenty of other ideas for coding as well as more advanced kind of concise type videos in the future. So I'll see you later. Have fun.